Hi, this is Robson, and I'll be demoing my project 2 for the temperature uh, module. Um, Here you can see this is all written in Rust using Arduino HAL and the DHT11 crate to interact with the temperature and humidity sensor. So we just have our imports and enabling interrupts, or enabling the feature to have interrupt handlers, a couple convenience types for the default serial port and the sensor, some other constants for the timer. So we're using the timer 1 for the interrupts to trigger when to read the temperature, and timer 1 has a maximum interval length of, I believe it's about 4.3 seconds or something like that, 4 seconds ish, and we need to read it every 10 seconds. So we're setting the interval to 3.3 seconds, and we only actually take measurements every third interrupt. And that's with the prescaler of 1024, which is the largest prescaler. And we have our calibration values. The calibration factor I never actually used. I don't know if that would ever really need to be used. It sounds like if you need to use this, your device is just broken. And then the offset, I probably didn't need to use, but when I was comparing my temperature readings to temperatures from just like a normal thermometer, they looked to be slightly lower, so I just add 0.5 to it. And then the Rust crates don't have a built-in millis function like with the normal Arduino stuff, so we have to keep track of the timing ourselves. So that's what these are for. And then keeping our temperature timestamp readings, whether or not the sensor is ready. There's no real concept of there's no volatile keyword in Rust. So there is a read and write volatile function, like read volatile and write volatile. But the suggestion from the embedded Rust book is to just use a higher level primitive like atomic bool instead. So that's what I've done here. And I had to do that because without using volatile, the compiler was optimizing away the reads to sensor ready because it doesn't see that it's ever actually changing. And then just some globals for the sensor itself and the serial output, or the serial port. Here we have our interrupt for when the timer goes off, timer 1. And when the timer goes off, we update the millis counter. So this is just us keeping time because because we don't have the millis function. And we get the sensor, and every third interrupt we perform the measurement, get the temperature, set the temperature and timestamp, and then set our sensor ready value to true so that the task code knows to send it over the serial port. And then it resets the interrupt counter, so we only perform the measurement every 3 times. So that's the interrupt. That's all the handler does. And then in our main function for our task code, we get the pins. We set up the timer and the serial port. We get the you can see here it's connected to D11 is the data pin. And then we create this sensor struct that's defined down at the bottom of the file, which has our DHT11 sensor and the delay that it needs to be able to perform measurements. And then we just delay a little bit to, make sure it's set up. It's recommended that you delay a bit before you start doing stuff with the temperature module. Then we set our timers up, which we'll look at in a second, and enable interrupts. And then we just loop forever, where we check if the sensor is ready. If the sensor is ready, we set it back to false and read the timestamp and temperature. This free function here is it's just taking this as a closure. So it is doing this. It's the same as doing disable interrupts and then enable interrupts, but then you don't have to worry about ever forgetting to re-enable interrupts or something like that. So that's all that's doing. So we get our timestamp and our temperature, and then it reads the temperature in tenths of degrees Celsius. So we get the Fahrenheit value from that, and then multiply by our calibration factor, which we're not using, and then add our calibration offset, which is 0.5. So this is the real temperature in Fahrenheit. And then to be able to format it to our output properly, we can't use the normal formatting for float to a string because for like an F32, because we don't have access to the standard crate. We're using core since it's embedded. So we just get the whole part of the float and the fractional part to 2 decimal places, and then write it out as timestamp, and then the temperature reading. Oops. And then this is the code to set up the timer that's called at initialization. We get the number of ticks, I suppose, that are required. So this is like how often, the interval for how often we want the timer to go off, and then the prescaler and the clock frequency. And this is how we get the number of ticks. We set up everything with the counting time, and this is just hard coded right now because the default clock frequency is 1.6 million, I think, or whatever it is. So this is based on that. And then we set the registers for the timer, and that enables the timer to start going and call the interrupt handler when an interrupt is generated. And then these are just our functions, our utility functions for reading and writing the atomic bool for sensor ready. And then our sensor holds that the DHT11 sensor and the delay that it needs, so that when we perform the measurement, both of those are already there. And what we can do here is, if I go to cargo run release, it doesn't work if you do it in debug. You have to, it won't compile in debug, gets a linker error. But if you run it as release, it will flash it to the chip, so that you just saw it blink a little bit. So that was it flashing, and now it's running. And now I'll swap over to this project, which is the one that runs on the I guess the host machine. That's just listening for the serial. It opens the serial port and listens to it. You have to give it the port and the baud rate. And it just sits there and listens, looks for a new line, because we're writing it as a string, and with a new line at the end. So it listens for the new line, splits everything up, and writes it to a CSV. So now if we run this, oops, I didn't give it the baud rate. So this is on COM3, and the baud rate is 9600. Now you can see every 10 seconds, about, where it's off by 1 millisecond, because it's 3.33333 every 3 times. We get the timestamp and the temperature, and that gets written out to, I'll let it go a couple times. I'll cancel this, and then it gets written out to this temperature data.csv file, and this is what we use to check everything and plot the temperature over time. So you could use the milliseconds as, you know, the first one is the time that you receive it, and then keep track of the actual time, like UTC or whatever actual time you want to use from the host. But it's just reporting it in milliseconds from when the program started running, which I believe is as soon as it has power. And this is actually a bug. You can see this, it like went backwards in time. I think it's because I'm not, where's the buffer? I think I'm not clearing the buffer. No, this is right. Yeah, I think I'm not clearing the buffer because this 9 shouldn't be there. It would be correct if it was 59994 and then 69993, 7, yeah. So that's what would be correct. So this one, and we can see, yeah, it is in here incorrectly. So I'll have to fix that. But I think the buffer that it's reading into, I'm just not clearing out first. But yeah, that's how this all works. And thanks for watching. I think that's all. Thank you.